Find the value of self-inductance of a very long solenoid of length L, having total number of turns equal to N and a cross-sectional area A. The number of turns per unit length of the solenoid is N upon L. Therefore, the magnetic field at any point within the solenoid on passing a current I will be B is equal to mu 0 into N I upon L. Therefore, the total flux linked with the entire solenoid will be phi is equal to B into A into N. Phi is equal to mu 0 into N into I into A upon L into N. Phi is equal to mu 0 N square I A upon L. Therefore, self-inductance L is equal to phi upon I, that is equal to self-inductance L, that is equal to mu 0 N square A upon L. Two long solenoids are of equal length L, and the smaller solenoid having a cross-sectional area A. The smaller solenoid is placed within the larger solenoid in such a way that their axes coincide. Find the mutual inductance of the system. When a current I1 is flowing through the smaller solenoid, the magnetic field strength within it is given by mu 0 N1 I1 upon L, where N1 is the number of turns for the smaller solenoid. The flux phi2 linked with the larger solenoid due to this field is phi2 is equal to mu 0 N1 N2 I1 A upon L. Therefore, M21 is equal to phi2 upon I1, that is equal to M21 is equal to mu 0 N1 N2 A upon L. If we now consider the situation in which a current I2 is flowing through the outer solenoid, the field inside it is given by mu 0 N2 I2 upon L, where N2 is the number of turns for with the larger solenoid. The flux phi1 due to this field linked with the inner solenoid is phi1 is equal to mu 0 N1 N2 I2 into A upon L. Therefore, M12 is equal to phi1 upon I2. Therefore, M12, that is mu 0 N1 N2 A upon L. From the equations, M21 is equal to mu 0 N1 N2 A upon L, and M12 is equal to, that is mu 0 N1 N2 A upon L. We find M21 is equal to M12 is equal to M. Two coils placed near each other have number of turns respectively equal to 300 and 600. On passing a current of 3.0 amperes through coil A, flux linked with coil A is Phi A is equal to 1.2 into 10 raised to minus 4 Weber. Flux linked with coil B is Phi B is equal to 9 into 10 raised to minus 5 Weber. Find 1. Self-inductance of A. Self-inductance of A is equal to flux linked with A upon current through A is equal to 1.2 into 10 raised to minus 4 upon 3.0 Weber per ampere is equal to 4 into 10 raised to minus 5 Henry. Find 2. The mutual inductance of A and B. The mutual inductance of A and B is equal to flux linked with B upon current through A is equal to 9 into 10 raised to minus 5 upon 3.0 Weber per ampere is equal to 3 into 10 raised to minus 5 Henry. A conducting loop of radius r is placed concentric with another loop of a much larger radius r, so that both the loops are coplanar. Find the mutual inductance of the system of the two loops. Take r is greater than r. Consider a current I passing through the larger loop. The magnetic field at the center of this loop due to this current is. It is given that r is greater than r. Therefore, the field in the region of the smaller loop can be considered to be uniform and of the above value. Therefore, B is equal to mu 0 into I into r square upon 2r square raised to 3 by 2 is equal to mu 0 into I upon 2r. Therefore, the flux linked with the smaller loop is given by Phi is equal to mu 0 I upon 2r into pi r square is equal to mu 0 pi I r square upon 2r. Therefore, mutual inductance M is equal to Phi upon I. Therefore, M is equal to mu 0 pi r square upon 2r.